Hello everyone, welcome back to another video. This is the fifth part of environmental statistics in which we are going to know about the moments of distribution. In today's video, we will discuss about skewness and kurtosis in detail, and at last we will also see some questions regarding this topic. For better understanding of this topic, you must watch the previous videos. In case if you haven't seen them, you can check it from the link given in the description. Now, let's know about the skewness. In the previous video, we have already discussed about the properties of normal distribution curve which has zero skewness. Normal distribution curve has three parts. First is the right tail, second is the left tail, and third is the middle part where the mean, median and mode coincides at the peak. Because of its symmetry, the normal distribution curve has equal length of right and left tail. But when any frequency distribution is not symmetrical, it is said to be skewed, or in simple words, skewness can be defined as lack of symmetry. The curve can be positively skewed or negatively skewed. If the curve has the longer tail towards the right, it is said to be positively skewed, but if the curve is having longer tail towards the left, it is said to be negatively skewed. Because of lack of symmetry, the skewness occurs, and if any curve is skewed, so here the mean, mode and median will not coincide, but the mode will displace mean and median. So in positively skewed distributed curve, the mean is greater than mode, whereas in negatively skewed distributed curve, the mode is greater than mean. If we talk about the quartiles, here the first quartile is displaced towards the skewed tail. So in positively skewed curve, the first quartile is towards the right, whereas in negatively skewed curve, the first quartile is towards the left. Next is the absolute measures, which are known as measure of skewness and which is equal to mean minus mode. The absolute measures tells us the extent of symmetry, whether it is positive or negative. If mean is greater than mode, it will be positive, whereas if mean is less than mode, it will be negative. Next is the relative measures, which are known as the coefficient of skewness and is given by beta 1 is equal to third moment divided by second moment. The coefficient of skewness is given by three formulas. First one is the Karl-Pearson's coefficient of skewness, which is equal to mean minus mode divided by standard deviation. Second is the Bowley's quartile coefficient of skewness, which is equal to third quartile minus 2 multiplied by second quartile plus first quartile divided by the interquartile range. Third is the Kelly's coefficient of skewness, which is equal to 90th percentile plus 10th percentile minus 2 median divided by 90th percentile minus 10th percentile. Now let's know about kurtosis. Kurtosis is used to describe the peakness of any curve distribution when compared to that of normal distribution, or we can say that the kurtosis describes the height of any curve. Karl Pearson described kurtosis as measure of convexity and he gave three terms. First is the mesocurtic distribution, second is the leptocurtic distribution, and third is the platycurtic distribution. Mesocurtic distribution is the case of normal distribution where the peak is not too high or flat. In leptocurtic distribution, the curve is very higher and sharp, whereas in platycurtic distribution, the curve is flat. The measure of kurtosis of frequency distribution is based on the fourth moment about the mean of distribution and is given by beta 2 is equal to fourth moment divided by second moment. If beta 2 is equal to 3, it will be mesocurtic, that is normal distribution curve. If beta 2 is greater than 3, it will be leptocurtic, whereas if beta 2 is lesser than 3, it will be platycurtic curve. Now, let's know about the moments of distribution. Moments of distribution are described as the arithmetic mean of various powers of deviations taken from the mean of distribution. The first moment of distribution is equal to x minus x bar divided by n, and it measures the mean of the distribution. As earlier we have studied that when we calculate x minus x bar and add it, then all of these values comes out to be 0. So the first moment of distribution is always 0. The second moment of distribution tells us about the variance and it measures the spread of the different terms in a distribution. The second moment of distribution is given by the first moment power second, and it is represented by sigma square. So when we square the first moment, all the negative values become positive, which will give us a positive number but no 0. The third moment is the cube of the first moment and it tells us about the symmetry of any distribution and the skewness. The third moment of normal distribution is always 0, as when we will cube the first moment, again the negative values cube root will give us negative and the positive value cube roots will give us positive, so our net result will be 0. The fourth moment is the fourth power of the first moment and it measures kurtosis. It highlights on the height of frequency distribution whether it is more peaked or flat or top than normal. Here the first moment and the third moment for normal distribution is always 0, but the second moment and fourth moment for normal distribution may be any positive number but not 0. Now let's solve some questions to recall what we have learned today. After reading the question, I will wait for some seconds so that you can also guess the answer. The first question is, which of the following measures of skewness is based on the distance of upper and lower quartiles from the median value in a data set? So here our correct option will be option third, which is Bowley's coefficient of skewness. Next question is, which of the following is the correct relation for a negatively skewed distribution? Here the correct option will be option first, which shows that in negatively skewed distribution the mode is greatest and the mean is the least. Next question is, which of the following statements are correct? Statement first is the log normal distribution is positively skewed, and the statement second is a negatively skewed distribution has its long tail to the left. So here both these statements are correct. So our correct option will be option first. Next question is, the third moment of a distribution of a data set of observation is measure of which of the following? So here our correct option will be D, which is skewness. Mean is the first moment, variance is the second moment, skewness is the third moment, and the kurtosis is the fourth moment of distribution. Next question is, if the mean of the following Poisson distribution is 4, so the second moment of the distribution will be as in the case of Poisson distribution, the mean is equal to variance, which is the second moment. So here our correct option will be option D. Next question is, which of the following statements are correct regarding skewness? This statement first is, for a positively skewed distribution, the value of the mean is the greatest among the mean, median and mode. For a negatively skewed distribution, the median is greater than the mean. Statement third is, Karl Pearson's coefficient of skewness always lies between the limits plus minus 1. Statement fourth is, Bolle's coefficient of skewness always lies between the limits plus minus 1. So here, after eliminating statement third, we will get our correct answer, which will be option 4. The Karl Pearson coefficient of skewness lies between the limit plus minus 3. That's all for today. Hope you liked it. Till then, thanks for watching.